Hey guys, Dr. Brown here, and tonight this is part 3 in our 3-part series relative to integrating sine x. And recall, we did the integral of sine squared x dx, and then the next video we did the integral of sine cubed. But we said during those videos, hey, why not just do sine raised to the n? So we've done that. So now we're going to walk through how we did that. Hopefully, we'll see how it turns out. And there's a few key, I don't want to call them tricks, but just a few insights that have to occur to be able to pull this off. Okay, so let's get after it here. All right, we have the integral of sine x to the n, or sine to the n x. You know sine x raised to the n is the same as this. They're raising the sine function to the n, sine x to the n. So I'm going to write them like this because every other function we deal with is written like that. And if you're taking the derivative, it makes it easier to see, at least for me, than this. Okay, so just know that's what's going to happen. Alright, so having said that, let me change this one. That's the integral of sine x raised to the n dx. Okay, well, to move on, why don't we change that to the integral of sine x to the n minus 1, and that times sine x to the 1, just raised to the first power. So you'll know, you recall the rule, if I have a to the m times a to the n, that's a to the m plus n, which is exactly what I have here. So if I have n minus 1 plus 1, that equals n. So that's the same as this. So that is the key fundamental to pulling this off. Now then, let's use the DI method and integrate this by parts. So DI, and we have a plus minus. And you can already see, at least in my mind, when I was looking at this, if I know I can integrate sine x easily. Well, I can integrate both of these, but sine, well, I take that back. I can integrate this one. This one would be easier to take a derivative of, and when I take the derivative, because of the chain rule, I'm going to end up with a cosine term. And I really need that if I'm going to integrate this row. So it has the key ingredients here. So let's write down sine x to the n minus 1, and sine x, we're going to integrate this one, differentiate this one. All right, let me scoot this over a little bit. All right, so now bring the n minus 1 down, we're differentiating this. N minus 1 times sine x to the n minus 1 minus 1, which is n minus 2. Now chain rule to the derivative of what's on the inside, which is the derivative of sine is cosine x. Now derivative of x, which is dx. Okay, the integral of sine, the derivative of sine is cosine, the integral is minus cosine x. Okay, so now let's work with our diagonal, and then we're going to integrate this row. So what would we have here? We've got negative, I don't want to lose that. So this equals negative, and I'm going to put the sine terms first. Sine x to the n minus 1 times cosine x, that's a negative cosine x. Okay, now that, and I've got an integral here, but it's negative times negative, which gives me a positive n minus 1, which is something it's a constant, so I can put that on the outside, times the integral of sine x to the n minus 2 cosine x, but it's times another cosine, so that's cosine. In this case, I am going to put cosine squared x. Well, we'll keep it the same as the other. Cosine x squared dx. Okay. Well, how can we change cosine squared x or cosine x squared? That's 1 minus sine squared, right? So I'm going to take this and put it over here for just a moment. We've got sine x to the n minus 2 times, and I'm going to change this cosine squared to 1 minus sine squared. I'll write it this way for just a moment. Now I'm going to distribute the sine x to the n minus 2 to the inside. So sine x to the n minus 2 times 1 is just sine x to the n minus 2 minus sine x to the n minus 2 times sine x squared. Now what does this give me? Sine minus 2 plus 2. The 2's canceled. I'm left with just sine to the n. So it gives me sine x to the n minus 2 minus sine x to the n. Okay, and all of this was falling under this integral. So this becomes what goes inside this integral sign here. All right, so what do we have? Minus sine x to the n minus 1 cosine x plus n minus 1, the integral of this first piece, sine x to the n minus 2, I'm just going to put them as two separate integrals, minus, and n minus 1 is times all of this, so times all these terms, times minus n minus 1, the integral of sine x to the n dx. Now you'll notice we have this integral of sine x to the n dx, the integral of sine x to the n dx. Oh wow. Sine x n to the dx, integral sine x n to the dx. Now I've got an n minus 1 here, but I've got a repeating terms. You remember on the DI method, when you get to terms that repeat, it gives you an opportunity then to do something with that. So what I'd like to do is add n minus 1 integral of sine x to the n dx to both of these. So I'm adding n minus 1, the integral of sine x raised to the n dx. Okay? And that couldn't have got any sloppier, I think, dx. Now then, some folks the integral may mess them up. I actually have one of these. 1 plus n minus 1, the 1's cancel, and I just end up with n times the integral of sine x to the n dx equals, these cancel, so these two are gone, and that equals minus sine x to the n minus 1 cosine x plus n minus 1, the integral sine x to the n minus 2 dx. Well, I need to multiply this by 1 over n to get rid of that. So I'm going to multiply that by 1 over n. That cancels. This by 1 over n. And this by 1 over n. So now you'll see these go away, and I end up with the integral of sine x to the n dx equals minus 1 over n sine x n minus 1 cosine x plus n minus 1 over n, the integral of sine x to the n minus 2 dx. Whoa, plus c. Alright, so that should be, yes, what we have here. Now, our challenge was, could we put, let's say, n equals 2 into this and get that? That became our challenge. Well, let's see what we can do here with that. I'm going to erase a little spot here. All right, so let's let n equal 2. So we would have, well, let's do it here. N equals 2 minus 1 over 2 sine x to the 2 minus 1 cosine x plus 2 minus 1 over 2, the integral of sine x to the 2 minus 2, which would give me sine x to the 0. And that just becomes any number raised to the 0 is 1, so I just have the integral of dx there. So I have minus 1/2 sine 2 minus 1 is 1, so sine x cosine x plus 2 minus 1 is 1, so I have 1/2 the integral of dx, which is x. Alright, so what did we have in this? We had up here, we're stating sine squared x. This should equal 1/2 x, which I do have here, minus 1/4 sine 2x. Ooh, okay, all right, we've got to figure out if that's the same. All right, let's assume we have a 30-degree angle, so we have pi over 6. So that would be 1 square root of 3, 2. That's what the sides would be. So in this case, on the integral of sine x to the n, we have minus 1/2 sine x. So sine would be 1/2. So minus 1/2 times 1/2, and then cosine would be square root of 3 over 2 plus 1/2 times pi over 6. So what does that equal? Square root of 3 over 2 times 4, square root of 3 over 8, square root of 3 over 8, and that's a negative, plus pi over 12. So 1/2 times pi over 6. Alright, so this one we have 1/2 pi over 6 minus 1/4 sine of twice the angle. So if our angle is, so 2 times pi over 6 obviously is pi over 3, and that's what this side is, because this one's 90, that's pi over 2. So this, what's the sine of twice 30, which is 60, which would be opposite over hypotenuse, which is square root of 3 over 2. So this all becomes pi over 12 minus square root of 3 over 8. Minus square root of 3 over 8 plus pi over 12. Wow. All right. That one worked. Now let's try n equals 3. All right, I'm going to take this out of here. I should get all of this out. All right, one down. I think this was kind of a cool problem here. I noodled around on it for a while before I figured out what to do. All right, n equals 3 So now then, we have minus 1/3 sine x to the 3 minus 1, which would be 2, cosine x plus 3 minus 1, which is 2, over n, which was 3, the integral of sine x raised to the 3 minus 2, which is 1, dx. Okay, minus 1/3 sine squared x cosine x plus 2/3. And what do we have up here? We had sine cubed was equal to, well, let's finish this out because I can do that integral. So minus 1/3 sine, I'll go ahead and put it back like that, in that form, cosine x plus 2/3. Now the integral of sine, derivative of sine is cosine, so the integral is minus cosine x. So minus 1/3 sine squared, oh, there it is right there, minus 1/3 sine squared cosine x, so we have that, minus 2/3 cosine x. These were cool, I enjoyed it. So now we'll start on, we'll do cosine. Cosine squared, cosine cubed, cosine to the n. Tangent squared, tangent cubed, tangent to the n. And then I guess we'll get into cotangent, cosecant, some of those. Okay, this was cool. Why are we doing this? We're retired with nothing else to do, I guess. No, we're actually trying to just get people to just get excited about math so that together we can build a better tomorrow and do that through math. You know, there's high-tech jobs out there, guys. Get the skills to go get those jobs. Earn a good living, okay? And the way to do that is be better tomorrow than you are today. Whatever your skill sets are, I would assume since you're looking at this video, then you enjoy math. So practice those skills. Many jobs out there, and that the need for those high-tech jobs is growing every day. Be a part of that solution. All right, that's all for now, and we'll talk to you next time. Thanks.